In the far reaches of our solar system, there is a world full of mysteries and beauty known as Triton, the biggest and most interesting moon of planet Neptune. It was the first Neptunian moon to be discovered on October 1846 by English astronomer William Lassell. Triton is one of the few moons in the solar system known to be geologically active. Active geysers were discovered erupting sublimated nitrogen gas and contributing to a tenuous nitrogen atmosphere. Let's travel this beautiful world with me and explore its unmatched beauty in detail. As I mentioned earlier, we will need to travel near the end of our solar system. Triton is the major moon of the planet Neptune. It is also one of the most remarkable body in the solar system. Although its orbit is unusual, circular and close to Neptune, but highly inclined to the planet's equator. Furthermore, Triton's sense of motion is retrograde, which means it moves in the opposite direction to Neptune's spin. Its revolution around Neptune has become a nearly perfect circle with an eccentricity of almost zero. Triton's rotation is tightly locked to be synchronous with its orbit around Neptune. It means it keeps one face oriented towards the planet at all times. Its equator is almost exactly aligned with its orbital plane. Triton's history, therefore, must have been quite different from those of regular satellites, such as the moons of Jupiter, which orbit in a retrograde sense in their primary equatorial plane. The modern consensus is that Triton originally formed in solar orbit and was subsequently captured by Neptune's gravity. Moons in retrograde orbit cannot form in same region of the solar nebula as the planets they orbit, so Triton must have been captured from elsewhere. It might therefore have originated in Kuiper belt, a ring of small icy objects extending from just inside the orbit of Neptune to about 50 astronomical units from the Sun. Thought to be the point of origin for the majority of short-period comets observed from Earth, the belt is also home to several large planet-like bodies, including Pluto. Triton is only slightly larger than Pluto and is nearly identical in composition, which has led to the hypothesis that the two share a common origin. The proposed capture of this moon may explain several features of the Neptunian system, including the extremely eccentric orbit of Neptune's moon near it, and the scarcity of moons as compared to the other giant planets. Triton's initially eccentric orbit would have intersected orbits of irregular moons and disrupted those of smaller regular moons, dispersing them through gravitational interactions. Triton's eccentric post-capture orbit would have also resulted in tidal heating of its interior, which could have kept Triton fluid for a billion years. This inference is supported by the evidence of differentiation in Triton's interior. This source of internal heat disappeared following tidal locking and circularization of the orbit. Recent hypotheses suggest that before its capture, Triton was part of a binary system. When this binary encountered Neptune, it interacted in such a way that the binary dissociated, with one portion of the binary expelled, and the other, Triton, becoming bound to Neptune. This hypothesis is supported by several lines of evidence, including binaries being very common among the large Kuiper belt objects. Triton is the seventh largest moon and 16th largest object in the solar system, and is modestly larger than the dwarf planets Pluto and Eris. It is also the largest retrograde moon in the solar system, also with a diameter 5.5% that of Neptune. It is the largest moon of a gas giant relative to its planet in terms of diameter. It has a radius, density, temperature, and chemical composition. similar to that of Pluto. Triton's surface is covered with a transparent layer of annealed frozen nitrogen. Only 40% of Triton's surface has been observed and studied, but it is possible that it is entirely covered in such a thin sheet of nitrogen ice. Like Pluto's, Triton's crust consists of 55% nitrogen ice with other ices mixed in. Water ice comprises 15 to 35% and frozen carbon dioxide in the shape of dry ice, the remaining 10 to 20%. Triton's mean density implies that it probably consists of about 30 to 45% water ice, including relatively small amount of volatile ices, with the remainder being rocky material. Its surface area is 23 million square kilometer, which is 4.5% of Earth or 15.5% of Earth's land area. Triton has an unusual high albedo, reflecting 60 to 95% of the sunlight that reaches it, and it has changed only slightly since the first observations. By comparison, the moon reflects only 11%. Its reddish color is thought to be the result of methane ice. It's a long history of melting. Model of its interior posit that Triton is differentiated, like Earth, into a solid core, a mantle, and a crust. Water, the most abundant volatile in the solar system, comprises Triton mantle, enveloping a core of rock and metal. There is enough rock in Triton's interior for radioactive decay to maintain a liquid subsurface ocean to this day, similar to what is thought to exist beneath the surface of Europa and a number of other icy outer solar system worlds. Triton has a tenuous nitrogen atmosphere with trace amount of carbon monoxide and a small amount of methane near its surface. Its surface temperature is at least minus 237.6 centigrade. Turbulence at Triton's surface creates a troposphere, a weather region, rising to an altitude of 8 km. Streaks on Triton's surface left by geysers plumes suggest that troposphere is driven by seasonal winds capable of moving material of over a micrometer in size. Like Pluto, a haze permeates most of Triton's troposphere, thought to be composed largely of hydrocarbons and nitriles created by the action of sunlight on methane. Its atmosphere also has clouds of condensed nitrogen that lie between 1 and 3 km from its surface. All detailed knowledge of the surface of Triton was acquired from a distance of 40,000 km by the Voyager 2 spacecraft during a single encounter in 1989. The 40% of Triton's surface imaged by Voyager 2 revealed blocky outcrops, ridges, troughs, furrows, hollows, plateaus, icy plains, and few craters. It is relatively flat. Its observed topography never varies beyond a kilometer. Fact craters observed are concentrated almost entirely in Triton's leading hemisphere. Analysis of crater density and distribution has suggested that, in geological terms, Triton's surface is extremely young, estimated 50 million years old to just an estimated 6 million years old. 55% of Triton's surface is covered with frozen nitrogen, with water ice comprising 15 to 35%, and frozen carbon dioxide forming the remaining 10 to 20%. The surface shows deposit of tholins, organic chemical compounds that may be precursors to the origin of life. Triton is the only icy body known to feature cryolava lakes, although similar Cryomagnetic extrusions can be seen on Ariel, Ganymede, Charon, and Titan. It also has the second largest volcano in the solar system by area named Leviathan Petra. A light feature, roughly 100 km in diameter, seen near the equator. Surrounding this caldera is a volcanic dome that stretches for roughly 2,000 km along its longest axis. This feature is also connected to two enormous cryolava lakes seen northwest of the caldera. Because the cryolava on Triton is believed to be primarily water ice with some ammonia. These lakes would qualify as stable bodies of surface liquid water while they were molten. This is the first place such bodies have been found apart from Earth. Voyager 2 probe observed in 1989 a handful of geyser-like eruptions of nitrogen gas and entrained dust from beneath the surface of Triton in plumes up to 8 km high. Triton is thus Earth, Io, Europa, and Enceladus, one of the few bodies in the solar system on which active eruptions of some sort have been observed. All the geysers observed were located between 50 degrees and 57 degrees south, the part of Triton's surface close to the subsolar point. This indicates that solar heating, although very weak, at Triton's great distance from the Sun, plays a crucial role. Triton geyser may last up to a year, driven by the sublimation of about 100 million cubic meters of nitrogen ice over the interval. Dust entrained may be deposited up to 150 km downwind in the visible streaks, and perhaps much farther in more diffuse deposits. Voyager 2's images of Triton's southern hemisphere show many such streaks of dark material. Its south polar region is covered by a highly reflective cap of frozen nitrogen and methane sprinkled by impact craters and openings of geysers. Little is known about the North Pole because it was on the night side during the Voyager 2 encounter, but it is thought that Triton must also have a North Polar ice cap. The high plains found on Triton's eastern hemisphere cover over and blot out older features, and are therefore almost certainly the result of icy lava washing over the previous landscape. The plains are dotted with pits, which are probably the vent from which this lava emerged. The composition of the lava is unknown, although a mixture of ammonia and water is suspected. 4 roughly circular, veiled plains have been identified on Triton. They are the flattest regions so far discovered, with a variance in altitude of less than 200 meters. They are thought to have formed from eruption of icy lava. The plains near Triton's eastern limb are dotted with black spots, the maculae. Some maculae are simple dark spots with diffuse boundaries, and others comprise a dark central patch surrounded by a wide halo with sharp boundaries. The maculae typically have diameters of about 100 km and widths of the halos of between 20 and 30 km. There are extensive ridges and valleys in complex pattern across Triton's surface, probably the result of freeze-thaw cycles. Many also appear to be tectonic in nature and may result from extensions of strike-slip faulting. There are long double ridges of ice with central troughs bearing a strong resemblance to European lineae. These faults with parallel ridges expelled from the interior cross-complex terrain with valleys in the equatorial regions. The ridges and furrows are thought to be of intermediate age in Triton geological history, and in many cases to have formed concurrently. They tend to be clustered in groups or packets. NASA's Voyager 2 spacecraft gave humanity its first glimpse of Neptune and its moons, Triton, in the summer of 1989. Voyager 2 obtained this parting shot of Triton, Neptune's largest satellite, shortly after closest approach to the Moon and passage through its shadow. The phase angle was 155 degrees, so that only a thin crescent of Triton's south polar region can be seen. Features as small as 100 km (62 miles) across can be seen in this color image of Neptune's satellite Triton, photographed by Voyager 2 on August 20, 1989. NASA's James Webb Space Telescope shows off its capabilities closer to home with its first image of Neptune. Triton can be seen shining with all its glory. Triton could get a visit from a NASA spacecraft called Trident, the proposed Trident mission named for its three-pronged approach to solving Triton's mysteries, inspired by the three-pronged spear carried by the ancient Roman sea god Neptune. Its plans to visit Triton and study the moon's entire surface in greater detail, according to a statement from NASA.